All right. Hello, everyone. Thank you for joining us tonight at ETH Global. I'm Sean from the ETH Global team, and I am honored to be joined here by Xiaozhou from Celer. Xiaozhou, would you like to introduce yourself?
Hi, everyone. I'm Xiaozhou Li. I'm a co-founder at Celer Network and leading the blockchain-related development efforts at Celer. So today I'm happy to introduce to you guys about our new initiative, which is called Layer2.finance. Its goal is to scale DeFi protocols in place on Ethereum. Yeah. Okay, so let's start. First start with a very quick overview of what Celer is doing. So Celer is a layer 2 scaling platform. We have been here for 3 years and building all kinds of layer 2 scaling techniques. What we already have been doing include the state channel network, which is the first project we started. It's a highly scalable and deeply optimized generic multi-hop state channels. And we have, if you're interested, you can check out the code open source. This has been running on mainnet for 2 years. And we also have a project called State Guarding Network, which is an efficient watchtower sidechain. Because as you guys know that most of the layer 2 scaling, they have one common challenge is how do you protect layer 2 data? Like there's always been like a challenge period for example, the state channel optimistic rollup and many other projects. So we are building an efficient watchtower sidechain to address this availability data challenge issues. It has also been running on mainnet since last year. It currently only supports monitor for the state channel network, but we will extend it to also support the monitoring service for optimistic rollup system, including our upcoming Layer2.finance rollup systems. Now, today's focus is Layer2finance, which is our new product. At high level, it scales the layer 1 DeFi interactions directly in place with layer 2 rollup. And later I'll talk about what does it mean by in place. So yeah, the code is open. The on-chain contract code is open source. They're welcome to check out and contribute. And we are currently running a testnet on Ropsten. It has been running since last week. And it's pretty active. I think there has already been more than 200 DeFi transitions, like investor sell transitions so far, more than 200,000. And it's working pretty well. Yeah. Except I think there are 2 times system state recovery due to the Ropsten long range reorg. So Ropsten recently had a reorg of 80 blocks or 40 blocks respectively. That caused us to have to recover some states, but still keep all the funds safe. Yeah. So yeah, welcome to try out our testnet. The web UI UX will be significantly improved soon. So now it's more like a MVP UI interaction. It will be updated very soon. Okay. So what is Layer2.finance? Why are we building this? The motivation is clear. The DeFi operations today are expensive. I don't think I need to talk too much about this. Everyone knows this. It's hard for small players to participate. So it becomes more and more like big whale games. Right? Then with the emerging technology of rollup, including ZK rollup and optimistic rollup, and people are generally asking, like, can we move all those DeFi protocols to layer 2? Let's just do everything at rollup layer. So this is a very exciting future that we all hope to come soon. But we also understand that it's not that easy because it involves the migration of the whole ecosystem, including all the related layer one contracts and all the other infrastructures like non-layer one infrastructures that are currently working with the Ethereum mainchain. So this whole ecosystem migration may not be that easy and smooth. And moving DeFi protocol directly to layer 2 rollup system may cause liquidity fragmentation because those big whales may not want or may not need to move their move operations to layer 2, right? Because the transaction gas cost is acceptable to them. So they could just prefer to stay on layer 1 and do as your business. So, and also another problem is the protocol composability. So it is similar to the ecosystem migration. So you have to make sure that all the protocols you want to interact are also on the same layer 2 rollup systems and have the same properties, similar the liquidity, pool size, all those properties. Yeah. So we hope this could come soon, but it may not be that easy. So what we choose to do, our Layer2.finance to do is to not ask to move DeFi to layer 2 rollup system, but move layer 2 to DeFi instead. So we build a rollup system to pull user requests in the layer 2 rollup, and then aggregate these DeFi interactions in layer 1 to directly still interact with all the original DeFi protocols in layer 1, like Compound, Aave, or the Uniswap, you name it. So in this case, we can greatly reduce the average per operation cost, amortizer cost of each user, and still maintain the same ecosystem, basically all the previous concerns I raised above is gone. So we believe this is a much faster path for layer 2 for this rollup plus DeFi adoption in the Ethereum ecosystem. Okay, now here's the more deep dive of the high-level system architecture. And so we have a set of contracts. In general, it's a roll-up contracts. It is a domain-specific roll-up. It takes the our pre-compared logic of how to deal with all those DeFi operations. And the roll-up contracts can talk to a bunch of strategies that also developed for our Layer2finance system. We have already developed a few strategies, and we welcome the community to also contribute to this part to develop as many strategies as possible that they can be easily plugged in and to interact with the rollup contract. And these strategies will talk to the existing DeFi protocols in layer 1. So the high-level user overflow is like this. So the clients make a one-time L1 deposit on L1 into the rollup smart contract. Say deposit 5,000 USDC, for example. And then the rollup submitter will pick up this deposit and know that, okay, now this client has this much of assets in the system. Then the client can send strategy operations to the rollup block submitter, the layer 2 server. It is currently a single server, and later can be extended to a sidechain. But then the raw block submitter will collect a user's request. Say, I want to buy some shares of this of strategy 0, I want to sell strategy 2, I want to sell some from strategy 1 and use that money to directly buy something in strategy 3, like all those normal financial operations you want. And client can specify this their operation intents. And the rollup block submitter will collect all those clients' operation requests with their signature metadata, of course, and then pack them into a rollup block periodically, and commit that rollup block into the on-chain rollup contracts. So the high level of the rollup thing is similar to others, right? So the contract will only store the block hashes and pass the call data used for later dispute. Yeah. So currently we are using optimistic rollup approach, and we are also looking to collaboration with other ZK rollup provider as well. But our current system is built upon optimistic rollup. And then also the users, all the clients aggregated intents will be, the hash of all the aggregated intents will be stored on the rock contracts. And after, there will be a few hours, for example, dispute window. After that window, the block submitter can execute the block and do the aggregate operation. Say that I collect these few hundreds of operations from tens of hundreds of clients, and in aggregate, they want to say commit 10,000 to strategy 0. They want to withdraw 20,000 from strategy 2. So there will be to each strategy there will be a single external function call, and the strategy then will do some simple internal processing and interact with the DeFi protocol itself. Yeah. So this is the high level user flow. You can see that it is straightforward. The way it saves cost is obvious. Right? It reduces the ON client request, the ON on-chain cost to O1, basically to aggregate all the client's intention of the same strategy into only one operations. Yeah. So yeah, this is the high-level thing, high-level overflow. So now going to some deep dive code overview. Right? So this is the rollup contract or core function and the structs. So in each block, we have root hash, intent hash, which summarize what this block, how this block want to interact with the strategies, and metadata, block time, block size. Yes, technically we can further compress these values into one single hash. But for this first version, which is for simplicity and correctness, so we keep 4 values stored on chain. And we have basic operations like deposit, withdraw, commit block, which is the block ID, and a list of transactions, which I'll talk about later, which is the either call data, and execute block that you submit the intended transactions again to actually interact with the DeFi protocol, with the strategy. And of course, because it is an optimistic rollup, you can dispute if the validator, if the block submitter submitted an invalid state. You need to submit all the related transaction and account proof. So I'm not going into details about the dispute logic, but if you're interested, you can take a look at our code. We have a full dispute cycle. Yeah. And these are the some of the important transactions that user submitted all block submitter summarized to submit to the blockchain, right? One is a commit transaction. It's more like buy shares. So that the user says, I want to buy this, buy some asset amount from this strategy ID and have a timestamp and signature. And we have uncommit transaction, which is the user want to sell their shares, which is, in our system we call it ST token, strategy token. So when you invest your asset like USDC DAI, you will get a corresponding ST DAI of ST token of that strategy. And in the uncommit transaction, you can see that I want to, for this strategy, I want to sell my ST token and get my original asset back. And also withdraw transaction that I want to withdraw my idle balance back to L1, back to my L1 account. And there's another important transaction, which is the commitment sync transaction. This one is generated by the block submitter. So in each block, in each raw block, the block submitter will look at all the client's commit and uncommit transaction and generalize a summarized transition. Yeah. Okay. So previously I briefly talked about the high level of our architecture to give you an overview of how the systems works. But in the upcoming hackathon, and so we will be focusing on helping communities to build the strategies. As you can see, which is this part, the strategy 012. So these are decoupled, loosely coupled with our core rollup logic. And they have very simple interface. They're very easy to be extended and flexible configuration. So I'm going to give you a quick overview of what a strategy looks like. Now you should be able to see this open source Layer2finance contracts code GitHub repo. And if you go to the contracts strategy, you can take a look at the overview of how to develop a strategy and how to test your strategy. Like you should read through this to build things and submit for the hackathon. So here is the interface of the strategy, which is pretty simple. So we have get asset address, which is just to return the token address. Like currently we support the single token strategy only. It means that each strategy only have one, like a DAI is one token. If you want to do with something like multi-tokens DeFi protocols, then you may need to do the swap, single token swap to multiple token within your strategy. The strategy interface currently only support one token. Yeah. And then the next, the two most important functions that the rollup contract, which is the strategy controller to interact with, are this aggregate commit and aggregate uncommit. So the aggregate commit is the controller only method, right? It moves the specific amount of asset from the controller, which is the rollup contract, into the underlying DeFi protocol. Yeah, symmetrically, the aggregate uncommit is also a controller only method that moves the specified amount of asset from the DeFi back to the controller, right? Which is like if the user's aggregated intent is to withdraw some amount of money from the strategy, this aggregate uncommit should be called. And we also have harvest and sync balance. So harvest is need to be implemented when the protocol provide additional yields, for example, in the form of governance tokens or other tokens like a COM token, right? So then this harvest, what this harvest should do is to sell the tokens, sell the additional tokens, transfer them into the asset token, and reinvest into the protocol, into the DeFi protocol. And but be aware of those flash loan attacks when implementing this method. So you should restrict this method to externally owned accounts to only, yeah. And the sync balance is just to return the balance of the asset token managed by the strategy. I think in many DeFi protocols, it only needs to be a view function. But in some DeFi protocols, it may need to synchronize the balance with the protocol before returning to it. But I think in most cases, the view function is enough. Now I can go over with some simple examples. You can see that we already have a few strategies built on, and there are pull requests for more strategies, which you can also take a look. So you can start with the very simplest, like strategy dummy, which we use in order to test our rollup framework. Right? So this is like the dummy strategy, which is not a real one. Right? So the aggregate commit is just a transfer the amount from rollup contract from the controller to this address. Aggregate commit is to transpect. Sync balance is just to get the current address. And this harvest, because we are going to mimic the harvest behavior. For this harvest, we currently in this dummy contract, we specify an external funder that whenever you call harvest, you get some token from an external funder which is to simulate the behavior that whenever you harvest, your asset increase. So yeah, this is like a strawman strategy contract to show like the very simplest function of it. And we can maybe take a look at some, for example, this compound as example, which is a real strategy that we are planning to launch on mainnet soon. So for example, you can see that it is not long. It is it is simple as well. So get strategy address, sync balance, easy. This harvest, you claim the COM token, get the COM token, and go to Uniswap to sell it, to sell back, to swap the COM token into the underlying asset like DAO USDT and reinvest into COM to compound. Right? Aggregate commit is to receive the money from the rollup contract, which is a strategy controller, and to invest those funds into compound. Aggregate uncommit similar like to redeem underlying asset from compound and transfer back to the rollup channel, to the rollup contract. Yes, it is that simple. Right? So because compound itself is a relatively simple strategy, and some others we also have AVE, which is even simpler, and we also have a curve, which is a little bit more, but it's still simple. Right? So you can see that building such strategy doesn't require a lot of effort. You just need to put an adapter between a Layer2.finance rollup contract and the actual DeFi protocols. And yeah, you can use your imagination to build more complex strategies, like for example, to interact with interact with multiple DeFi protocols or do whatever investment combination you like, as long as you conform to the simplest strategy interfaces. Yeah. And another thing about the strategy, so what would it requires if you want to hook up your strategy with the Layer2.finance. So we, in our smart contract, we also have a registry contract that you can register assets, which is what types of tokens asset you want to support and which registry you want to, the system want to support. So in our current version, we allow only the contract owner to register this register strategy, and later this will be extended as a governance function to let the community to use the governance power to decide which strategy should be integrated into the system. What else? I think that's pretty much of this. Yeah. So the please take a look at the detailed look out for this this README and related links to see how to, and also all these examples to see how to build a strategy. So that's pretty much of my my technical walkthrough of Layer2finance. We are continue building. So what's next? We will mainnet launch our current version soon as the alpha launch, and we are continue developing more features and more and improvements in the upcoming releases, like more strategies and some flow improvements, which may require some strategy interface changes, but the high-level concepts will stay the same, and we'll do gas cost optimization. Currently, I think each user like commit, uncommit, like Layer2 deposit with withdraw transaction, I think it's cost about 5,000 gas, and we believe that could be optimized. And yeah, we'll have more features like asset and ST token transfer within the L2 systems, and the fee structure, governance, etc. Yeah, that will be coming soon. Okay, I think that's it. Thank you very much. I'm happy to take questions if there's any. I don't see any questions, but we will also be on Discord of the hackathon, and we have our own Discord and a Telegram. Yeah, basically there are multiple channels to ask questions later. We will be happy to answer you. Thank you.
Awesome. That was a very informative and educational presentation. Really appreciate it. A question for you. Someone would like to have, if someone would like to have the slides, is that possible?
Sure. Yeah, definitely. This is the, yeah, maybe I can just share the,
yeah, you can
share the slide link to you. Yeah, I'll share the slide later. Yeah.
Awesome, sounds good. Someone in the chat asked if, wait, sorry, yeah, never mind. Oh yeah, someone in the chat asked, where's L2 code running?
Yeah, so L2 code is not open source yet, so we will open source part of the Watchtower challenging part soon, and we are seeing like how much of the internal business logic will be open source and how much of the community features will be open source. So at the bottom line, we will definitely open source all the Watchtower challenger, like how to submit the block and how to reconstruct all the layer 2 states from the on-chain contract and discover if there are any malicious of fraud blocks, and how to dispute the submitted blocks. Yeah, all those logic will be open sourced. Yeah, because we are currently still actively develop and improve the code. Yeah, that part is not open source yet.
Awesome, sounds good, and good luck to the developmental efforts. We're excited to see what's gonna come up with that. And if anyone else has any questions, please feel free to like drop them into the sponsor channel. So under sponsor dash Celer. But yeah, unfortunately we're out of time. But thanks to everyone for coming. Appreciate y'all for coming so late at night. But like this was very, very nice, enjoyable, and